I think all good now. Okay. I just wanted to tell a business use case and then discuss a business use case so that everybody of us, including me, when I was making this PPT, understand why basically we need Databricks and what is it used for, because data has been here in this world for long time, even before computers, right? So why do we need these data pipelines, especially in this now? And then I'll try to explain it with a simple use case so that everybody of us will get up to speed. Who is the stakeholders and where exactly Databricks is used in this pipelines? Okay, don't go by the data pipelines and the ML pipelines. We're just discussing about the data pipelines. Okay, and ML pipelines is an extension to the data pipelines. As in we progress, you'll get to know. Okay. So firstly, I was just wanted to let you guys know that using data pipelines, you are doing something with data. Um, so what is that we are doing is a question, right? So one thing we need to understand is data is dirty in the sense that most of the times only you need very few data. You have enormous data, but you just need only 2 or 3 columns or 2 or 3 pieces of data from this enormous data. Okay, and that's where the data pipelines comes into picture. Now let us take an example of a store which is Costco. I just take an example. It is selling an A2 milk. Okay, A2 milk is a premium milk, and then its shelf life is very less, and then they want to know how much you need to order, right? We'll take this example, and there are 300 stores around here, assuming there are 300 stores, and which store needs how much, right? And the agenda is understanding data pipelines, and I don't say understanding ML pipelines. We just say like when we'll just stop where ML pipeline starts. Okay, that's where it. And then real world example, like I just explained, and then traditional data versus Databricks, and then implementation data. Okay. Now, what is the data pipeline? In any data pipeline, there is 3 main steps. Okay, extract, transform, and load. You extract the data, you transform the data, and you load data to something else. And that something else could be ML pipelines. It could be business intelligence platform where user, and it could be some reporting platform where user goes and sees what data is. I mean, how the data looks in the way he wanted. Okay. So, and what it handles, data pipeline handles huge amount of data. Okay. It could be petabytes. And I worked in a data pipeline, not in Databricks, not per se Databricks pipeline, in traditional data pipelines where there is an ingestion of 100 to 200 GB per hour also. Okay. And this is a real world example, as I said. What is the challenge, right? What, let us take a company wanted to order the A2 A2 milk, right? Costco wanted to order A2 milk from its supplier for all its stores. Why? We want to optimize inventory levels because we don't want to take too much of the stock, keep it with us, and then distribute to our shops, because the shelf life of this product is very less and it goes bad after this store. So that's a cost to the company. So they wanted to, and they don't want to order less number and lose the customers because because they lose the business. So don't want to do. We want to strike a balance between these. So that's where we need to improve the supply chain efficiency, and that's where the uh, data pipelines comes into picture, because we do something with the data, we analyze the data, and then we predict it. And we could predict in multiple ways, that's fine, but we predict it, right? So that's what. Okay. And what are the data sources? So for us to analyze the data, to to clean the data and then give it to the prediction or somebody else, so that company will predict to see how much of data is, how much of milk is needed. So we need to get data to run into the pipeline, right? By the way, if you have any doubts, you could actually stop me in between. Okay. So yeah, so then what is the source of the data? Source of the data is daily sales. Okay. And the daily sales could be in a database, in a system. We collect it in, remember, in ETL there is an extract. We extract that data from this system, whether it's a daily sales, whether it's a plain files, whether it's a database, right? And it could be and current stock levels also. Okay, current stock level meaning what is the current stock and what is the one that are sold, and how much might be needed, right? So we also consider, say for example, a store wanted 30, sells 40 day, now there are 10 already in its store, so we just need 30, so that current stock. Okay. And then sometimes in an advanced stage you could also collect the weather data and then see how much you need, right? Because it's a cold weather, it's a rainfall location, you might need less, but this isn't very advanced, but I'm just. So what are the sources of data? Sources of data is basically your daily sales and what is your stock, and then it could be, that is the daily source. And then the technology point of view, it could be a CSV file, it could be a database. Okay. Now the traditional, okay, data has been here, so data pipelines has been here for long, right? And what is the difference between traditional pipeline and Databricks pipeline, right? Okay, traditional pipeline, as we said, data source, we ingest, we process, we store data somewhere, and we send it to ML or for other serving platform where to get the some report. So we stop here to storage, right? Data sources. What are the data sources? Whatever we just saw. And ingestion. Ingestion is a compute layer, or a, how would I put it? A business logic layer, right? I mean, from data sources you ingest it into business logic layer, and processing is the business logic layer actually. So where you do some of the massage to the data. Okay, what is ingestion layer? There are two kind of ingestions: streaming batch jobs, and then Kafka or S3 or to the database JDBC. These are ingestion layer. What is the processor layer? The processing layer is how you want your data to look like. Okay, Apache Spark, Apache Airflow. Okay, and then storage layer. Where do you store after processing? You could store in S3, you could store in any Delta lakes and data lakes, and you could store in warehouse. Okay, and then these ML flow serving Kubernetes API, all these are like for the later stages in the ML. But what is we need monitoring, Prometheus and Grafana. Why we need to monitor is to continuously improve the data pipelines, and that data pipelines, how much the data is stored using the memory, how much is stored on, how much time is processed, it's taking all those things, right? So that's the traditional pipeline. So in the traditional pipeline, so we collect the milk data, okay, milk data, and provide it to the API connectors or API connectors, because it's a batch processing. Then the Apache Spark and all those will actually pre-process the data, process the data, like it, because I said data is dirty, right? And the data will have duplicates, and the data will have null values, and the data will have all these uh, off values. Off value meaning something like away from its median. So what we do in processing of data is we take this sales data, milk sales data, and then what we do is we fill null values with some sort of median values, and we actually remove the duplicate lines. Those is called as processing data, and the data that comes as it is from the sources is called as a bronze data in this world, right? It's called as bronze data. And the data we process, like removing the null values and all, is called as silver data. Okay, and the data that is used by the reporting or ML is called as gold data. So if there are 100 fields in a data, for example, in our A2 milk, there are 100 fields in the data, and then most of them have few of them has null value. We fill in null values, and then there are duplicate entries. We remove those duplicate entries, and then that is called as silver data, and that is done by our processing layer, so that we could predict the right milk, right? So, and then out of 100 fields, we only need 3 fields in it to predict. Okay, we don't need all 100 fields. We only need 3 fields. Processing layer doesn't consider that. It just makes the data clean. Okay, and then so silver. After cleaning, you put into silver layer, right? And then we again take only the 3 fields that are needed for reporting or ML service. Then we put it in a golden layer, and then golden storage. That is called as gold data, and that is used by ML. Okay, so and now there is 15 different fields with traditional architecture, right? It's the same thing that we explained. We don't need all this. This is just our inventory. Then it goes to Kafka, as I said, and API connectors. Then get the S3. Then get to the processing layer. Then stores into data lake. Okay. And then why do we need traditional architecture? We have complexity, 10 to 15 tools. We need to learn all of them, time consuming, and then infrastructure. We need to, and then everybody has a skills. Team silos means everybody has a skills, and then, it's not in single person's hand like that. And then cost inefficiency, we need to cluster running every time. There is no efficiency of the infrastructure, and then it takes time, all those kind of things, and it's cost high, and then slow deployment, right? So now the Databricks platform enters, right? So Databricks, as we said, it can ETL pipelines, and it also has an ML development and all, and then real-time processing, which is streaming, which Aishwarya will actually explain more on the data, but I will explain the architecture point of view, right? So we auto load into the ingestion, okay, and then it stores as a bronze data, live tables, and then gold features. The way you run this data lake to the live tables like bronze, silver, and gold, okay, is basically by using your notebooks or a Python code or a framework called DBT. DBT is data build tools. You build the data for ML. Okay, that's why the name data build tools, right? So when you have a milk, okay, when you have a milk with data with you, what you do is you write a SQL file so that the data with the DBT, it's a template, so that it will be with bronze, silver, and gold. Okay, we'll convert the data into DBT. That's a technology. I think I'll park it later. I can give a data DBT live session, the working session. But for now, assume that you have a tool. It could be a code, but DBT is a better tool which converts your data, raw data, bronze data, into silver and gold data, right? And then it is help for serving the model. So now you have, as you say, you have 100 fields, and you use DBT to do a silver data, cleaned data, by filling the null values, by filling the median values, by removing the duplicates. And then you also convert it to features data by only taking those columns from 100 columns. You only need 3 columns. That DBT does, right? And then Databricks replaces all the traditional tools. Okay, and it's an on-demand infrastructure, and you could auto scale it and auto scale down it so that you are cost efficient, and it's very faster, right? To build a data pipeline by developing business logic by yourself, trust me, it will take months. But remember that we just had, and then we are now somebody will be demoing this, right? That simple it is. Even to get to this stage, it takes months because you have to write business logic for so many layers, and then you have to write a deployment logic. You have to create an infrastructure. All this it takes at least a month. But now you just read the documentation and put together a small simple pipeline. Okay. So that's how we implemented. I actually covered this data bricks with A2 sales prediction at the same time while talking. So is just that is just that the slides are later, but I compared it already, and then we just uh, so that's how we, with a simple example, that's how I wanted to explain the traditional and the data bricks. That's it. I'm done. Any questions?
Yeah, thanks, Shiva. I mean, this was amazing. I mean, I especially like the traditional architecture representation slide where you go through various layers, and then for each layer, what is the tool
Yeah,
you used.
this one.
Yeah, this one, this is too good a slide. I mean, so clear. I was able to easily understand how the data flows, the ingestion, processing, what, especially the tool required for each ingestion processing. That was very clear and precise to me. And even I liked your comparison slide, tool slide, which compares between Databricks as well as a traditional, giving a overall understanding of how powerful Databricks is. Thank you so much for simplifying this for us.
My pleasure. Yeah. So next time we'll run with the data. We'll see how simple it is with the building these layers, like we say, this bronze, silver, and gold layers, because it takes a lot of time and effort with traditional pipeline, but with some DBT tools, it's like really simple. Actually, these three really, really simple.
Yes, thank you.
Yeah, I think over to Aishwarya. I think she will actually show the meat of